Hello, I hope you are doing well. I am Madam Gracious Kanzieni from Educare Tanzania. Welcome for a session. We are proceeding with our subject of chemistry and our class level is Form 3. And today we are proceeding with our topic, which is the acid, base and the salts. And we have started the first subtopic, which is the acids, and we are proceeding with this concept of acid. Today we are going to see about the strengths of the acid. When we talk about the strength of the acid, here we are going to see the strong acid and the weak acid. And why we are going to see about the strong acid and weak acid? Because of the dissociation of these compounds. When it dissolves in water, it tends to classify the acids strengths in different ways. We can have the strong acid and the weak acid. Now let us see one after another. By starting with the strong acid. By definition, strong acid is the acid whereby all atoms present in acid dissociate completely in water to give hydrogen ions and negative ions associated with the acid. Katika strong acid, in this compound we are going to see that those compounds tend to dissociate completely. Yani yenyewe ina dissociate completely to form the associated ions. And it tends to give the hydrogen ions and the negative ions which are associated with the compound. But the aim of why it is strong acid, it is because it tends to dissociate completely. My dear student, note that the strong acid tend to dissociate completely. Yani ina dissociate completely. For example, let's say hydrochloric acid, when dissolved in water, tend to dissociate completely to get the hydrogen ion, which is positive charged ion, and we are going to have the negative ions associated with our compound, which is HCl. And another is sulfuric acid. The sulfuric acid tends to dissociate completely to have the hydrogen ions which is positive charge, and another negative ions which is associated with the sulfuric acid compound. Another example, consider the nitric acid. The nitric acid here, it dissociates completely to form the hydrogen ions which is positively charged, and another negative ions which is associated with our compound of nitric acid. My dear student, I hope that is clear for you kwamba tukiongelea zile strong acid tunaongelea zile acid ambazo zina dissociate completely kuzalisha ile positive ions of hydrogen, vile vile na negative ions nyingine ambazo zipo associated na ile compound ambayo ina dissociate. Now, when we talk about weak acid, hii itakuwa ni kinyume cha strong acid. Kwa maana kwamba hapa kwenye weak acid tunaona kwamba compounds they don't dissociate. It does not dissociate completely. Let us see the definition. Weak acid is the acid whereby all atoms present in acid dissociate partially in water to give hydrogen ions and negative ions associated with acid. So the aim of acid, we know that, is to produce the hydrogen ions which is positive charged ions only. That is the aim of acid. But when we talk strong acid, weak acid, here we are classified the strengths of the acid. Okay? So now you can see that the all atom present in the acid or our compound now, it tends to dissociate partial in water. Yani ina dissociate partial kidogo, so completely. You see, it's like the vice versa of strong acid. And when it dissociates partial in water, directly it will produce the hydrogen ions which is positive charge and the other negative ions associated with the compound. And you can see the example of acetic acid. This is an acid. Now you can see it decompose, it dissociate, into hydrogen ion, which is positive charge, but another negative ions, which is acetate ions, and this is related or associated with our compound. But note that hapa note kitu kwamba when we talk about complete dissociation, you can indicate with the full and direct arrow, full direct arrow, mshale ambao umekamilika. Lakini tukiongelea partial dissociation of a substance, here we are going to see hapa kuna half double half arrows. Kwa mfano hapa unaona mshale huu umeenda hivi, upo half, na huu upo half. So mean that this is partial dissociation, kwamba haija dissociate completely, kwamba kuna partial dissociation, as you can see here. Okay, now let us see the concept of acidic concentration. When we talk about acidic concentration, what does it mean? Concentration of acid is the quantity of the acid in the water. And when we talk about the quantity, this can be the salt that is within the water or our solution. Note that if acid contains very little or no water, is called concentrated acid. Kwamba if the quantity now is little, that is what we call the concentrated acid. And if the acid contain more water, is called diluted acid. Kwamba hapa the solution is more than those what consider the concentration, kwamba solution in a large amount or the quantity than the solute. Kwamba kama quantity or the water, quantity of water or that solution is large, that solution or that acidic concentration is now diluted. But weak or strong acid can be concentrated or diluted. Kwamba it can be weak or it can be strong acid, lakini inaweza pia ikawa diluted or inaweza ikawa concentrated. Kwamba inaweza kukawa na large amount of water or no large amount of water, ikawa ni concentrated na ni weak acid au ni strong acid. Vile vile inaweza ikawa na imecontain more water, ikawa ni dilute, ikawa ni strong acid which is diluted, au ikawa ni weak acid which is diluted. Now let us see the basicity of acid. When we talk about basicity, this means that the basicity of acid is a number of hydrogen atoms per molecule of acid that can be replaced by metal in a solution. Kwamba yenyewe ni number of hydrogens atom per molecule in each molecule, but we are considering the number of molecule of hydrogen. And this number of mole can be replaced by metals in a solution. Let us see the examples. Consider the basicity of acid below. You can see that here you have the acidic solution of hydrochloric acid, and it dissociates into hydrogen ion, which is positive charge ion, and you have chlorine, negative charge ions. But the basicity now is mono-basic. Why mono? Because the number of atoms of hydrogen atoms per molecule is 1. You can see here. Number of hydrogen molecule is 1. And also
Purchase your tracks today.